Okay, so tell me what you know about the tree diagram.
Well, I mean, you get the questions, and you just have to put in all the possible outcomes into a tree diagram.
Yep.
And from each of the so like that diagram shows, from each of the different
Yep. And,
possibilities.
how many numbers do you need to put in to complete the tree diagram? So if a question asks you to complete a tree diagram, completing a tree diagram, how many numbers do you need to put in, and what their characteristics, what's their features? So how many numbers?
I'm not too sure.
Okay, so you have, right, sorry, you have, here is 1 number, 2 number, 3, 4, 5, 6. Is that all?
For this specific example,
Yep.
I think that would be it.
Okay, so remember, there are more to it. So 7, 8, 9, 10. So there are 10 numbers that you need to write on this tree diagram. Right?
I'm sorry, I don't understand where 7, 8, 9, and 10 come from.
Okay, so let's just go on and read this paragraphs again, right? So if you later on they will just direct you to this question, right? They are quite similar. You see, that's 1, 2, 3, 4, 5, 6, and then you have
The
4
overall.
extra numbers at the end.
Right.
Okay, so whenever they ask you to complete a tree diagram, you have to not only write this the letters, the events, you have to also write down the 10 numbers. Then can you tell me, these 10 numbers are probabilities, right?
Mm-hmm.
Do you notice any pattern? How can you check that your numbers are correct? Like, more specifically, if 1 plus 2 equals what?
3.
No, that's not true. Okay, so let's take a look at this. Here is the example, right? So they actually completed it. You see, it's indeed a 10 numbers: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Mm-hmm.
So now let's look at 1 and 2. What is their feature?
Well, I guess they've written the possible percentage in a decimal.
What I mean is when they add up to
1.
1, right?
Yeah.
Now, you notice these two numbers, they add up to?
Also 1.
Yeah, and these two?
Also 1.
And these 4? Also
I'm
1.
assuming also 1?
Yeah, also 1. You see, check these add up to 1. So this is how you check your answers are correct. Right? And then it also helps you to do questions, because as you will see in many questions, they're gonna give you this. Let's say this is a 0.6. You directly know what is the probability of this.
0.4.
Yes. So that's how you figure some of these out. And then talking about this probability, number 7, right? What does it represent? So this is the probability of what?
The vice captain.
Right.
From the captain present to the vice captain present.
Yeah. So let's say if this is 0.6, what does this 0.6 represent? So this is the probability of what?
The captain's present.
Yeah, captain present, right? Now what about, let's say if this is 0.3, what does this represent?
The possibility of the vice captain present.
Okay, so this is not entirely correct. But then, how to calculate the probability of this? So if you go back to what did they calculate?
Well, that would calculate with would you times the 0.6 to the 0.3?
Yeah, exactly. So you are just multiplying along the branches, okay? Right? So that shows you how to complete the tree diagram, right? So you now know how to complete the tree diagram with the 10 numbers. Right? Does that make sense? Then you just have to make sure you understand what it means. 0.6 times 0.3 is 0.18. This number represents, what does it represent? It represents the probability that both captain and vice president present. So that means it's this and this, right? So it's like an and, right? So it's captain present and vice president present. That's what it means, right? So if you look back at the paragraph, this is why they use the notation PCV, right? Because C means captain present, V means vice president present.
Yeah, okay.
So that means both captain and vice president present. You times them together. Does that make sense?
Yeah.
Okay, no, you just have to understand this reading, right? What does V dash mean?
That means that the vice captain is absent.
Right, so it just means not present, right?
Yeah.
Okay, so C dash means not the captain and V dash means not the vice president, right? So list the outcome as the end of branch and calculate probability at each end. You multiply the probability along each branch because event and event 2 must occur, right? So this is a end.
Yeah.
Okay, and that's pretty much what it says in this example.
Yeah.
Right?
Okay.
And here it checks your probabilities in the right-hand column, add up to 1. The reason is that this is 100%, right? 1 means 100%. Something must happen, right? So one of these events must happen. So that's why it's add up to 1. Does that make sense?
Yeah.
Okay, and a similar reason for these ones, they add up to 1. 6, highlight the events required along their probabilities, add these to find the overall probability required. Okay, so in this question, they are asking you, so calculate the probability that both captain and the vice president are present in the assembly. Looking at this table, can you tell me the probability?
0.8835.
Fantastic, that's correct, right? Now, the second question, calculate the probability that the award will be presented in the assembly. Right, so they will tell you extra information, right, in the paragraph.
Right.
So they're telling there's a special teams award presented at the school assembly, and the hockey team has been chosen to receive the award. The award must be accepted by the captain, or if the captain is absent, the vice captain. Right? So it must be accepted by either the captain or the vice captain.
Yeah.
Right? Okay, so now, would you be able to tell me the probability that the award will be given?
It could be so it could be the first line, and it could also be the third line. So 0.8835 and 0.0375.
Okay, now let me ask you, is this one possible?
Yes, because the captain is present.
Yeah, so you see, you have to be careful, think about. So remember, in the wording, it says or, right? So it not says or, but we can summarize as or. So it turns out and or, these are two very important logic. Right? So it's and or, right? You have to carefully distinguish them, right?
Yeah.
Normally, in the context of a tree diagram, when we're doing or, in mathematics, we're talking about plus. Right? We're plussing, adding along branches. Does that make sense? And then for and, we are really multiplying.
Multiplying, yeah.
Yeah, because and we are really multiplying. Okay. Right, and then just remember that the adding up to 1 stuff, right? And you have 10 numbers to fill up. So let's look at one example, right? And this just to check, they showed you this result, right? You're just adding up 3 probabilities. And that's pretty much shows you how to solve these questions, right? So let's look at the first one. Again, so just you don't even have to look at the question, right? So what's this? What's this number?
So that would be 0.45.
0.45. What's this number?
0.4.
0.4. What's this number?
0.3.
0.3. And this number?
0.55 times 0.4.
Right. And this one is?
0.45 times 0.7.
Yeah, this one is?
0.45 times 0.3.
Right? Now, calculate the probability that a paper belongs to a boy who fails the test. So this question you have to understand what it actually means, right? So we've talked about the meaning of these probabilities, right? So this one is the probability of
a boy passing.
Yeah, a boy passing. What really happening in mathematics is you have to realize this is a boy and pass. Does that make sense?
Not really.
Because it is a boy and this person pass.
So how is it us then?
Well, the English you have to change it to math. So this is how you change it to math. In math, we really mean it's and.
Okay.
Okay, so this is just the wording that you have to understand. Okay, so let me just calculate these values. 0.22. This is 0.45 times 0.7, so this is 0.315. And this is 0.45 times 0.3, 0.135. Let's just take a look at this last one. This means the probability of a girl and fail, right?
Yeah.
0.45 means
the girl
probability is
probably girl.
Of a girl, right? Okay. Then the question is, what is this probability?
A girl failing?
Yes, but let me change it to math for you, right? So this is the probability of fail given it's a girl.
Okay.
Okay, so what it actually means is it's
so
easier.
The actual percentage of girls failing would be 0.1. Is that what you're trying to say?
Yes. So right. Okay, so let me just put it another way. Let's don't say this is a probability. Let's say there are 100 students. Right, so there are 55 boys. And then there are 45 girls. Right? There are, so 60% pass. What does that mean? That means out of those 55 boys, 60% of those 55 boys pass. So this is exactly the same thing. So this 0.3 actually means out of those 45 people, only 13.5 pass. Only 13.5. Okay. So 13.5 out of 45 is 0.3. Yeah. So it depends on what you're out of, right? But when we are multiplying these two, right? So, I mean, so the probability, so that's this is 0.45 previously, and this is 0.3. You multiply them together. Then this is 0.45 times 0.3 is 0.135. It means 13.5 girl. If you divide it by out of 100, that is this number, right? So this number is out of 100. This number is out of 45.
Right.
So this actually shows this is so that is the meaning of conditional probability. So you are shrinking what we call sample space. So it's no longer out of the larger picture, is now we're focusing on a specific subgroup. Right? So every number here is a conditional probability. So this is 0.6. It means in the probability is no longer divided by 100 students, it's divided by 55. Similarly here, it's divided by 55. Similar here, it's divided by 45.
45.
But
yeah.
Everything here is divided by 100. Does that make sense?
Yeah.
Okay, so that's what the difference. Now, the next thing you have to understand is all these language stuff. Right? So let's look at the language. So the first one, they are asking the calculate the probability that a paper belongs to a boy who fails the test. You have to. That's why, because in English we can write it as many different ways as we want, but in math we only have two logic. Is it and or is it or? And is it conditional or is it unconditional? By conditional we mean it's no longer out of 100. Unconditional is out of 100, right? With a smaller number, let's say 55, right? Let's say, right? First of all, is it and or?
Sorry, what is out of 100 again? Unconditional.
Unconditional, yeah. So that's the larger picture, right? So these are unconditional. These are unconditional, right? These are unconditional. Yeah. Because they are all out of 100. You say, if there are 100 students, I know 33 students out of 100 are both boy and pass. This one is unconditional because we know if there are 100 students, we know 50 out of 100 that are boys. But these are not. These must be out of 55. This must be out of 45. Right? I hope that makes some sense.
Yeah.
Okay? So now you have to decide which of these 10 numbers does this one represent?
Calculate the probability that the paper belongs to a boy who fails the test. So it would be the second row because it's from the conditional of a boy who fails. Is that right?
Okay, calculate the probability that a paper belongs to a boy who fails the test. Belongs to a boy who fails the test. Belongs to a boy who fails the test. It belongs to a boy. I mean, this is really. Can I change this phrase? So the paper belongs to a boy, and he fails. Are these two equivalent? I mean,
I wouldn't say so, because since you added the word "and," you're basically saying to multiply.
Yeah.
The amount of boys who failed.
To a boy who fails the test. Okay, so let's how can I explain this to you? Right. Okay, so to a boy who fails the test. Well, you will. So let me. I'll have to write a few sentences. Belongs to. Belongs to a person who fails the test. Well, I mean, I can't really explain the English. But this actually means the boy who fails the test. So it is 0.22. But let me think about a way to a boy who fails the test. So this is just describing the boy, right?
Right.
Am I right?
Mm-hmm.
So this is a clause that describes the boy. So they actually refer to, and then where is this paper selecting from?
The boys. So you're just timing 0.55 by 0.4, and that's how you get your answer.
Wait, so okay, so yes, but then I'm talking about first of all, right? So think about conditional and unconditional comes from this word, a paper. This one is unconditional. Why? Because so unconditional means we are dividing by 100. Conditional
Because
means
everyone's
we have
doing
to
the
divide it
paper.
by 55 or divide it by 45, right?
Mm-hmm.
But then since they not say, since they only say a paper, right? So we are selecting paper from the entire pool of papers.
Yeah.
Right? So it's actually unconditional.
Mm-hmm.
So your number must come from either this or this, right?
Yeah.
Does that make sense? And then
Yeah.
when it comes to a boy who fails the test, so there are two conditions. One is that a boy, second, it fails the test. It gotta be this one, right? I mean, so
Yeah.
that's how I work it out in my head. Right? We'll look at the other questions and then you will see that you will tell the difference, right? If I change it to a conditional, I would say it this way. I would say find that instead of a paper, I say that a boy's paper who failed. What's the probability that a boy's paper failed? Right? I would say. Does this make some sense? Okay,
Yeah.
so if I ask you, calculate the probability that a boy's paper failed, what's that probability? Is this conditional or unconditional?
It's conditional.
Yes. So the number has to be?
Out of 55.
Yeah, so the number is?
Would it be 0.4?
Fantastic. Does it make sense? It's not it's like both a game of math as well as language.
Yeah.
Yeah. So you must be able to know what's the subject of your sentence and what is the clause. What does the clause really mean in math? Right. So let's see more questions, and you will know what I mean. Right. Calculate the probability that a paper. So is it conditional, unconditional?
Unconditional.
Unconditional, right? So it's out of the entire. You must use this column and this column to help you. Belongs to a girl who fails the test.
So it'd be 0.135.
Fantastic. Awesome, right? So let's see more questions and you will see the difference. Wait, hold on. Right, questions Okay. Let's see, question D. Calculate the probability that a paper belongs to a boy.
Uh, 0.55.
Fantastic. So now, calculate the probability that a paper belongs to a student who has failed the test.
Would that be 0.7?
How?
Because it's saying, oh, actually, it would be.
Yeah.
It would be 0.22 and 0.135.
Fantastic, right? So you know that this is, first of all, this is unconditional, right? A paper, right?
Yeah.
So you'll be using numbers from this and this. And then belongs to a student who has failed the test, right? So you realize, oh, you can both have the boy fail the test and the girl fail the test, right? You're done, right?
Yeah.
And then if 1,600 students set the test, how many failed it? Okay, so let's just first calculate. This is 0.22 plus 0.135. 0.355. Okay, and then wait, sorry. This is the question wrong. It's so it's belong here. 0.22 plus 0.135 equals 0.355. Now, if 1,600 students set the test, how many failed it? So use this number.
So would you just divide it to 0.355, which would give you 4,507?
So let me change this question, right? Now, I'm going to say, let's say in the class, the probability of a probability of a boy is 60. No, let's use this, right? So remember that we did in year 10 that experiment. If we toss a coin, no, let's say difficult. Let's say rolling a die. The probability in a fair die rolling a 1. What's the probability? Roshni, what's the probability of rolling a 1?
1/6.
1/6. Okay, fantastic. Because you have 6 outcomes, right?
Yeah.
And the one favorable. Now, if I roll this die 30 times, what's the expected value of rolling a 1? How many times of 1 am I going to roll? Okay, now let's make it easier. If I roll this 6 times, yes. How did you get 5?
Because 1/6 of 30 is 5.
What is the mathematics calculation you're making?
30 times 1/6.
Exactly. Right. So now back to this question. I know the probability of fail is 0.355. If I have 1,600 students, how many fail?
But what would I have? Oh, wait, no, okay. Sorry, just give me a second.
Yep.
Would it be 568?
Fantastic. How did you calculate it?
I did 1,600 times 0.355 over 1.
Yeah, you don't have to put it over 1, right? Oh, okay, so you change it to a fraction. You don't have to do that. I can change it to 0.1666, right? So it doesn't really matter. It just remains you have to times 568. Now let's generalize this. I don't think they told you this, but this is a expected value.
Right.
So this is expected value of fail is the probability times by the number times by probability. So we call NP. But in math, NP is the expected value. Right? Just keep that in mind. N is the 1,600 and probability is 0.355. Right?
Yeah.
Okay, now calculate the probability that a paper belongs to either a girl or a student who has failed the test. Right? Either a girl or a student who has failed the test. Okay? Either a girl or a student who has failed the test.
Yeah.
Is it conditional or unconditional? Look at it again, right?
Paper belongs to either a girl or a student who fails the test. I think, well, the first part of it where it's saying a paper belongs to either a girl, that is, but so overall it would be unconditional.
Yeah, so this is English. You really have to think about English. So think about probability as you are picking marbles from a jar, right? So you are really thinking how many things you're picking from. Here, they're only saying a paper. So you are picking them out of the entire jar, which makes it unconditional. So it's only a paper. You see? A paper, a paper, a paper, a paper. Right? A paper. If they say it's conditional, they're gonna say calculate probability that a girl's paper.
Okay.
Right? Or they're gonna say a failed paper, something like that. But whenever they say pick up, so they're selecting a paper, right? So that's still unconditional. Does that make sense?
Yeah.
And then belongs to either a girl or a student who has failed the test.
So it'd be the last three.
Fantastic. Last three. You add them up, right? Okay. Last question. Calculate the probability that paper belongs to a boy who has passed the test.
Boy who passed. So that's 0.33.
Yes, right? And then they ask you to compare the answer to a previous one. So for the previous one, you added up these three, and for the last one, you add up. You only have this one. They add up to 1, right? That's what they're testing. Does that make
Sorry, could you just repeat that? Your voice cut out.
Okay, so the previous one asked you to calculate these three. The last one asked you to calculate this one. They add up to 1. That's what they are trying to ask you to do.
Ah, okay. So that's comparing.
Yes, so you have to know the feature of tree diagram. These two add up to 1. These two add up 1. These two add up to 1. These 4 add up to 1.
Yeah.
Yep. And these two represent unconditional, and this column in the middle represent conditional, right? Where this probability 0.6 depends on it's a boy. This 0.4 depends on it's a boy. This 0.7 depends on the girl. Depends we mean, if you think in this sentence, it means we're selecting a paper from the boys' papers. We're selecting a boys' paper. We're selecting a girl's paper. The probability that it fails is from a girl's paper, right?
I just have one question. So for that last bit where you times both of them together and it's out of a whole rather than just 55 or 45.
Yeah.
That is unconditional.
That's unconditional.
In the middle one, so the 0.6, 0.4,
let's think
0.7, and 0.3.
Yeah, so let's think about it.
Conditional.
I know what you mean. Yeah.
But what's the first one?
The first one is unconditional because it has an advantage as being the first event, boy or girl. You are essentially picking a jar right? Where the jar has both the boys and the girls, and the boys past and the girls past, containing all papers.
Okay.
Right?
Yeah.
You're selecting from all papers that 55% of those papers are actually belongs to boys. Right? Whereas this one in the jar, in your jar, in this column, is actually not all papers. You actually only have boys' papers. Right? Does that make sense? You only have boys' papers here.
I just want to know what that first bit meant.
This 0.55 is 0.45.
Oh no, I get what you meant now. I got it.
You got it? Are you sure?
Yeah. Yeah.
Okay, and the last bit, right? So it's boys and past. What it actually means is you're still getting all papers. And you just have 4 different colors. You have the boys pass and boys fail. And then you have girls pass as well as girls fail, right? Okay, so this is one out of the entire thing, right? So that's the difference. It depends on which jar you're picking it from. Right? So we're all good with this first question, right?
Yeah.
Okay, then the next question becomes a lot easier because this is very similar. These questions are very similar. Okay, so this is wait, where is that question? Second question. Wilmu. Wait, hold on. Yep, okay. So William walks to school, right? So what's this number? This number.
0.3.
0.3. Let me change the color. Now, what's this number?
0.6.
0.6. What's this number?
0.2.
I just want to give you a sense of what it looks like in the wording, right? So in your exam question, you will be asked not only to figure out some of these numbers, but every number. Let's see how to describe this 0.4, right? William walks to school on 70% of the day and bikes on the rest. If he walks, right? Then the probability he has time to make his lunch is 0.4. This is a conditional. This is a very obvious sign for conditional. You just have to do more of these questions so that you develop a sense of which is conditional, which is unconditional. So we are no longer picking the jar from every day. We are only picking from the jar it contains that he walks.
Yeah.
Right? So that's why we put this here, right? I hope that makes some sense. And then this is another way when they say it. When he bikes to school. So that we are no longer picking from the jar of every day, we're picking the jars that only contains that he bikes. Right? So that's why we put a 0.8 here. Right?
Yeah.
Okay, now what is this?
That is 0.7 times 0.6.
Can you interpret this probability? So the probability of so can you interpret it in English?
So the probability of people who walks and buys their lunch.
Yeah, so that's exactly what I want to hear, right? Because it's and, right?
Yeah.
And, right? So that's the key word. I mean, they can write it any way they like in English, because English is pretty flexible, but in math, I'd prefer, like, it's definitely preferable if you can have one way of thinking it. So I would encourage you to change it to either and or, and then think about conditional or unconditional, right? So then these are just easy, right? So 0.3 times 0.8, and 0.3 times 0.2. Now, how to check if your tree diagram is correct?
To make sure they're all equal to 1.
Yes, you see these two equal to 1, and these two equal to 1, these two equal to 1, and if you add up these four, they will give you 1, right? That shows you actually have a plausible tree diagram. Now, calculate the probability that on a particular day, William walks to school and buys his lunch. What's that probability?
Walks to school and buys his lunch. 0.42.
Fantastic. I think you're already very good at this. Right? So let's see. Calculate the probability that on a particular day, William bikes to school and makes his lunch.
Bikes to school, makes his lunch. 0.24.
Yep. Calculate the probability that on a particular William buys his lunch.
That'd be 0.42 plus 0.06.
Fantastic. Now let me ask you another question. What's the probability that William walks?
0.7?
Fantastic. Right?
Okay.
Be confident.
Yeah.
You just have to realize the last column here and here are both unconditional. This one is unconditional as a result it's being the first event. Right?
Right.
Okay. Now, calculate the probability that on a particular William will buy. Wait, we've done this one, right? Okay. If there are 40 days in a term, about how many days will William buy his lunch?
Buy his lunch.
Okay, buy his lunch. Just 0.42 plus 0.06. Okay, so 0.42 plus 0.06 is 0.48. Now, how to do this?
So how many days? 48. 48. 0.48. 23.04 days.
Right?
Yeah. So 23.
Yeah, so I think this is something in the exam in NCEA. They try to ask you to round numbers whenever plausible. So it's you should also write roughly equals to 23 days. Right? Calculate the probability that on a particular day, William will either walks or buy his lunch. Either walks or buy his lunch. Either walks or buy his lunch.
So it's 0.28 plus 0.42 plus 0.06. First, second, and third.
Fantastic, right? Now, this last question, look carefully. If he has made his lunch, what is the probability that he has back to school?
If he has made his lunch, what is the probability that he bikes to school?
Now, first, is this conditional or unconditional?
Conditional?
Yes.
Because it's out of his lunches?
Yes, it's no longer out of the jar of every day, right? It's out of the jars that only contains the marbles that when he made his lunch.
So he made it lunch.
What's the probability that he made his lunch?
0.4 plus 0.8. Is that right?
Let's say made his probability that he made his lunch. 0.28 plus 0.24. Does that make sense?
Yeah.
Right? So 0.28 plus 0.24 is 0.52. 2824, let me make sure. Right? That's probability of him making a lunch. What is the probability that he bike to school? So out of those probabilities, how many times
0.52 over 0.24.
It's actually, wait, does it say buy lunch? Made his lunch.
Oh,
right?
sorry.
Yes, you got it right. So it's 0.24, right? So it's actually 0. So out of those, wait, what's wrong? So out of those, it's no longer out of 1, right? So it's out of 0.52. He only biked to school on 0.24. Does that make some sense?
Yeah.
Okay. Right. So this is conditional probability. You realize it's conditional because we are not picking any particular day. We are picking only those days he made his lunch. And out of those days, he only made his lunch which are favorable. Bike to school. This is the favorable. Right? Does that make sense?
Yeah.
Okay, so you just do this by practice. But you have to aware what you're doing. Right? Is this conditional? Is this unconditional? Is this asking me and or is this asking me or? Right? Okay. Are we better now?
Yeah, I just still with the very first worksheet that you sent us, with the experimental probabilities.
I have to find it. I have to find it because let me try to find